Back up. Where'd that go? One time. Uh-oh. Where am I?
Sorry, what page is it?
This is page, good question, page 14. Yeah, we're on page 14. So we've looked at the sine and cosine formulas already, right? So we want to look at how the tangent formulas work. Same thing as before. I will give you these formulas. You don't have to have those memorized, but you have to understand kind of how they work, how they operate, okay? If you notice, these are a little bit more involved in that there's numerator and denominator. And if you notice, if it's minus here, it's minus on the top, and then it becomes plus on the bottom. So that means on the top, we're subtracting, and the bottom, we're doing 1 plus, and then it's the product. In other words, we're multiplying those two together, okay? And then similarly, if it's plus here, that means it's plus on top, and it's minus on the bottom. So I just want you to see some examples of how those work. Allison, put the food away, please. Okay. If you look back a couple of pages where we have we did our list of all of our special angle measures with our common denominators. If you flip back to those pages, what we're looking for is two angle measures, two radian measures that add or subtract to give us that 7 pi over 12. So if you look, that's not a good sign. Okay, so we're looking for two angle measures that add or subtract to give us that 7 pi over 12. So if we look at 3 pi over 12 plus 4 pi over 12, right, that's going to add to give us the 7 pi over 12. But when we rewrite this here for our benefit, we don't want to think of it as the 3 pi over 12 and the 4 pi over 12. We want to use the angle measures that we're going to be looking for in our unit circle, right? Okay, so let's rewrite this then really as the tangent of pi over 3 plus pi over 4, right? Is everybody good at why I'm using those two values, where those came from? Yes.
Are we going to get these, like, matching?
You'll get the formulas, yes.
But will we get the pi over 3 equals to, will we get all of those?
No, because you can figure those out, right? If you do your list, pi over 6, pi over 4, pi over 3, you can come up with and figure out what your common denominator is yourself.
Did we get the unit circle?
Yeah. Oh, yeah. No, you're going to get unit circle. You'll get the formulas. I'm not going to give you a list of these equivalent fractions because you can figure those out, right? And that's what I would suggest is first thing, that's what you do is kind of write out that list if you need it. Okay, great question. I'm glad you asked about that. Okay, so this is a tangent and it's plus. So let's go ahead and plug into the formula. So that looks like the left-hand side. We're going to plug into the right-hand side. So that means we're doing the tangent of pi over 3 plus the tangent of pi over 4 all over 1 minus the tangent of pi over 3 times the tangent of pi over 4. Right? Do you see? I'm just plugging into that formula for now. Okay, now we've got to go to the unit circle, though, and find those values. So here's the deal. We've got to remember now how we find our tangent values. Remember, tangent is y over x, or more specifically with these angle measures, it's the numerator of the y over the numerator of the x, right? Okay, so tangent of pi over 3. Eliza, what does that give us? Numerator of the y over numerator of the x. Root 3. There you go. So root 3 plus, and then tangent of pi over 4. Chloe? Numerator of the y over numerator of the x. 1. There you go. So we get square root of 3 plus 1. That's our numerator all over 1 minus, And then whatever values we just got, we're going to multiply them together. So the square root of 3 times 1 gives us the square root of 3. Okay? All right, here's the deal. If you notice, this is the part that's not so fun about these tangent problems. If you notice, now we have radical in the denominator, and we're not allowed to leave that there. So we've got to multiply by the conjugate to get rid of that radical, right? So that means we're going to multiply top and bottom by 1 plus the square root of 3. Okay, and we're going to do that on top and bottom. So in the numerator, we've got to FOIL all of that out. So Will, can you help me first? What's that going to give us?
Shouldn't it be like 100
What now? If we multiply the first terms, what do we get?
I don't know. Is it just
Okay, close up your screen and focus, and that will help.
Sorry.
So first term in each of those parentheses in the numerator. So that's this square root of 3 times 1. What does that give us?
Square root of 3.
Square root of 3. That's first. Outside, what does that give us?
Square root of 9, which is 3.
Which is 3. Good. Keep going. Plus inside.
1.
Good. And then last,
Square root of 3.
square root of 3. Beautiful. Okay. That's FOILing out the numerator. Okay, Vinay in the denominator. Technically we are FOILing, but remember our outside and inside, guys, is going to add to 0. So really we just have to do first and last. So Vinay, what do we get when we do first and last?
1 minus 3.
1 minus 3. Beautiful. Okay, now here's what happens. Notice we've got some like terms here. That we need to combine together. And when we do that, if you notice, we combine that 3 plus 1, we get 4. And then plus, we combine root 3 plus root 3. It's not very pretty looking, but that's 2 root 3. And then this is going to be all over negative 2. So guess what? We haven't talked about this in a while, but we've got Mickey Mouse ears. Remember, if you have a common factor in all 3 of these places, we can divide it out. So I want to think of this, I want to do the division, I want to think of it as dividing out a negative 2. So 4 over negative 2 gives us negative 2, and then the 2 over negative 2 gives us a negative 1. So this is going to be minus, and we can put 1 times root 3, or we can just put root 3. Someone started to ask a question. I thought I heard a question. Somebody start to ask a question. No? If you don't, on this type of problem, great question. If you don't get Mickey Mouse ears, you've done something wrong. Because your final answer should be, remember how all of our sines and cosines had a square root of 6 and a square root of 2 over 4, right? That was kind of the format. We just had to figure out the signs. Eliza, close that up, please. With these tangents, you're going to get a 2 and you're going to get a root 3. You're you're doing this to figure out your signs, whether it's positive or negative. So on this one, they're both negative here, but
Is there never going to be a denominator?
there should not be a denominator. And it should be a 2 and a root 3 if you're doing these right and you're doing a tangent problem. Okay? So that's the format that you should be looking for. So if you don't get, it's a great question, and that's something to remember. If you don't get Mickey Mouse ears, you know you've done something wrong. If your signs are messed up somehow and things add to 0 and disappear, then you know you've done something wrong. Okay? So that's something to keep in mind. All right. It's new, it's a different formula, so it looks kind of weird to begin with. That's why we have to practice with it, just to make sure we become comfortable with it. I've got to show you another little glitch, another little thing that tends to happen with some of these, and I want to show you that with this next example. And then we will talk about why I have this reminder on there, okay, on your page to help you remember this. So we'll talk about that in just a second, okay? All right, so now I want to look at tangent of 75 degrees, right? So we're trying to find two angle measures that add or subtract to give us 75. I want to use specifically, so that you can kind of see this little glitch that tends to happen, I want to use 45 plus 30. Okay, so thinking about the formula, go up here and look at the formula. We're using plus, so this is the format that we're going to use. So that means we're doing tan of 45 plus tan of 30 all over 1 minus tan 45 times tan 30. Okay, so we're going to unit circle. Tangent of 45, we look at that numerator of the y over numerator of the x. We know that gives us 1, right? So we get 1 plus. Here's where it gets a little bit messy. Remember, tangent of 30 degrees. Remember, we do numerator of the y over numerator of the x's. And then we had to rationalize that. So it doesn't look very pretty here because we end up with an improper, with a complex fraction here, right? So we get 1 plus root 3 over 3 for our tangent of 30. And then we do 1 minus, if we multiply 1 times the square root of 3 over 3, if we multiply that together, then we just get this. So remember, in the last problem, we had to deal with the fact that we needed to multiply by the conjugate. Here, we've got another step that we have to deal with, and it's because of this 30 degrees, right? It's because of the 30 degrees that we're in this position where we have this complex fraction that we have to deal with. So we've got one extra step to do, and that is we need to find common denominators and kind of clean this up a little bit. Okay, so if we rewrite the ones, if we rewrite these ones as 3 over 3 so that we have our common denominator, I want you to notice what we get here. So then we get 3 minus root 3 all over 3. Okay, take a look at that. Make sure you understand how I've kind of condensed that a little bit. And then I need you to think about what happens when we do a keep it, change it, flip it there. Guys, what happens with the 3's in the denominator?
Cancel out.
They do, they divide out, don't they? So the 3's divide out, and that means that we are just left with that. And now we're in the position, once again, that we've got to multiply by the conjugate, right? So what's the conjugate going to be in this case? Caden, what are we going to multiply by, top and bottom?
3 plus root 3.
There you go, 3 plus root 3 and 3 plus root 3. Okay, and now we've got a FOIL again. So I need help with that. Okay, so we're multiplying. Shane, can you help me with that? So we're doing first 9, good, plus outside, good, 3 root 3, and then inside, yep, 3 root 3, and then plus 3. Beautiful. All over, I'll give you a second to kind of think about that and process that and write all of that out. Remember, in the denominator, we're not going to have to FOIL completely, just first and then last, right? So first, Sophia, what's that going to give us? 9, and then minus last. Careful, it's root 3 times root 3, or root 3 squared, so what's that going to be? Just 3. Good. There you go. Okay, and then you're looking at common terms that we can combine together. So we've got that 9 and 3 that we can combine together, and then we've got these. They don't look very pretty, but yeah. So 9 plus 3 gives us 12 over, plus 6 root 3. When we add 3 root 3 plus another 3 root 3, we get 6 root 3. And then on our denominator, oops, there we go. We just get 6. And as Allison was asking previously, we've got Mickey Mouse ears.
Real here?
So once again, we should be dividing, right? So 6 goes into 12 and we get 2 plus 6 goes into 6. There we go.
So just do 2.
So 2 plus
root 3.
root 3. And that's the format that you're going to get for those. Yes.
Something with denominator, I'm kind of confused on how they cancel out, because it's like, well, I might have done something wrong, but for me, I got like -3.
Okay. So yeah, if you notice, we're getting similar format for this one as we did that other problem. But it's definitely more involved to have to deal with the whole complex fraction business and then deal with the conjugates. So that's why we want to try to avoid that as much as possible. So that's why, if you notice, I put this little note on your paper to remind you, if you can avoid using, because you can use whatever angle measures you want as long as it adds or subtract to get to whatever you need. If you can avoid using the 30-degree reference angles, and that's any 30-degree reference angle, so that means 30, 150, 210, 330. If you can avoid any of your pi over 6s, so pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. Try to avoid those if you can, because that's where we get into this more complicated stuff. Okay? Does that make sense? Will, Eliza, put the screens away. Close them up, please. No one should have screens open right now. Okay. Hang in there, we are almost done, and then I'll explain what I'm going to ask you to work on to practice with this, okay? So for these two problems, we are looking, I'm gonna pull this up on this screen. I don't know why it is that this screen is working for my MacBook and that screen's working for my iPad, but not vice versa. Anyway, that's what's going on. Okay. So if you look at the problem here in the notes packet, if you notice, this format looks like the right-hand side of what you see with our formulas. So the main thing is deciding, we know it's going to be the form of a tangent of something, right? We have to decide whether we're going to add or subtract. So the main thing to look at is what's going on as the sign in your numerator, right? So because it's a minus in the numerator of that formula, then it's going to be minus here. And then we're just plugging in the values that we're given. So 78 minus 18, right? So in other words, this is asking us to figure out what is the tangent of 60 degrees. So we go to our unit circle and we look for 60 degrees and find the tangent. Numerator of the y over numerator of the x. So tangent of 60 degrees, what do we get for that? Alice, what do we get?
Square.
Careful. Okay, square root of 3 over 2. There you go. Well, numerator of the y over numerator of the x. So square root of 3. There you go. Good. Okay. Awesome. So we good on that one? Okay. Now let's look at this last example. On this one, we actually kind of have to work both directions. So I'll show you what I mean with that in just a second. So to begin with, if you notice, what I want you to think about is the fact that sines and cosines are mixed together. So I've put the other formulas up here, right? Here's the cosine formulas. Remember, cosines, the cosines are together, the sines are together. So for the sine formulas, cosines and sines are mixed together. So we know this is one of the sine formulas. We just have to figure out whether it's a plus or a minus and then deal with the angle measures. So with the sine formulas, if it's plus here, it's plus here and vice versa. So since it's plus here, that means it's going to be plus. And that means we need to just enter these angle measures and do the math and figure out what that's telling us, right? So if we find common denominator and add those together, then this is saying we get 4 pi plus 12 plus 3 pi plus 12. So we get that this is equivalent to saying what the sine of 7 pi over 12 is equal to. But now we can go to our unit circle and come up with these values also. So we've kind of worked from right to left, but now we actually need to do the work here. So what's the sine of pi over 3? So Emily, sine of pi over 3, what do we get? Sine of pi over 3, be careful. It's the y. Remember at pi over 3, we're looking at the y then. Good, so the root 3 over 2 times cosine of pi over 4, Eden. Hold on just a second. Yep, root 2 over 2. And then plus cosine of pi over 3. Jace, what do we get there?
Cosine of what over?
Of pi over 3.
Would it be 3 cosine 3 over 2?
Careful.
Or not cosine, square root.
Cosine, remember, is the x.
Is the x, okay, so just 1/2.
So 1/2, good. So 1/2 times the sine of pi over 4, Ashley? Root 2 over 2. So we get our root 6 plus our root 2 all over 4. Okay, so on those, we kind of worked both directions there, didn't we? We worked to the left to come up with what it was really condensing to become, and then it also was giving us our answer. Be careful here, we're multiplying these fractions together. So when you multiply the 2 times 2, we'll get the 4. Okay?
So can you put either of those as your answer? Or is it like you have
It's actually that you're going to give me both parts of it. So you're going to tell me now that the sine of 7 pi over 12 is equal to this. So you're giving me both parts. Does that make sense? Okay. All right.